which says ABC is an equilateral triangle with side length 2. Okay, so AB is 2. A dash is chosen on the side BC such that length A dash B is K. Okay, so this is K and this is less than 1. That is why this A dash is lying on the lower half part of this BC. Likewise, B dash and C dash are chosen on the side CA and on CA and AB such that CB dash is K, so this is K, and AC dash is also K. So these remaining sides will be 2 minus K here, 2 minus K here, and 2 minus K here. Line segments are drawn from point A dash, B dash, C dash to their corresponding opposite vertices. So A dash to A, B dash to B, and C dash to C. The intersection of these line segments form a triangle labeled PQR. We have to prove that PQR is an equilateral triangle with side length of this. I think this can be said by symmetry also, but let us try to do it in proper manner. Okay, so first of all, what we can see here is this angle is 60 because it is equilateral triangle. Similar to this, this angle is also 60 degree, and there is one more triangle, that is this one. This is also 60 degree. Okay, now if you consider this triangle A dash B, A dash B, and then triangle B dash C, and triangle C dash A. Let me check. C dash A. I think they all are congruent to each other. Why I am saying congruent to each other? Because they have two sides, K and 2, K and 2, and K and 2, and angle included between them to be 60. So from side angle, side criteria, they are congruent. Okay, and if they are congruent, that means this angle here, I am putting a single dot here, will be equal to this single dot here, and this will be equal to this single dot here. Okay, and I'll put this double dot here. I'll put this double dot here, and there is one more triangle. I think this double dot here. Okay, now what we can conclude here, let us see. In these triangles, if you see like in this triangle A dash B, A dash B, I'm talking about this angle A I called as single dot, angle A dash I called as double dash, and angle B is 60. Angle B is 60. Now with this logic, in this triangle APC dash, APC dash, because already we have these two angles to be dash and double dash. Angle A is same, dash only. Okay, angle C dash is double dash here. Okay, so this remaining angle at P has to be 60 here, because from angle sum property, sum of these two is such that third angle is 60. So here also the third angle will be 60 here. So this angle has to be 60 degree. Okay, so similar to this, we can conclude that for R also and for Q also, this angle is going to be 60, 60, 60. So this angle in the triangle PQR, I can say PQR, all angles, angle PQR, they are 60, 60, and hence this is equilateral triangle. Now coming to the other part, that is the side length of equilateral triangle will be this thing. To do this, let me take one more slide for this. Okay, now to do this thing, let us do some similarity here. Let us try to find some similarity here. First, before that, I will be calling these lengths AP as A and A dash Q as B, and this length I will be calling as T, and we are supposed to find this T only. Okay, and if it is A, I think CR will also be A, we have proved these triangles to be congruent. So this here will be B, this here will be B, and this here will be A. This will be T here, this will be T here. Okay. Now as this angle is 60 degree, okay, using cosine rule, and this is K here, I can write cos 60 to be equal to 2 square, that is 4. I am taking this AB length as 2. This is given in the question actually. So 4 plus K square, 4 plus K square minus AA dash, which is sum of A, B and T. Okay, upon 2 into K, and cos 60 is 1 by 2. So simplifying it, we will be getting AA dash square to be equal to, I think if I bring this side, it will be 2K here. So this will be K square plus 4 minus 2K. Maybe it is the beginning of the solution of this, because here also we are getting similar kind of expression in the denominator. Now let us see how we can make use of this thing. So AA dash square is this. Now maybe we can find the value of A, B in terms of K, and that will help us to solve it. Now everybody please see, this angle I wrote as single dot there, okay, and this angle I took as double dot here, and this also we got as the double dot. Okay, so if you check, we are having two triangles. I'm writing one as APC dash. You can notice APC dash. Okay, and there is one more triangle which is A. At P it is 60 degree. If you remember, this angle was 60. So at P if it is 60, and I'll be taking A, then B, and then A dash. So you can check these two triangles are such, they have all the three angles to be equal. At A here single dot, at A in this bigger triangle also single dot. At P here we are having 60. In this other triangle at B we are having 60. At C dash we are having double dot angle, and at A dash also I am having double dot angle. Now if we compare the corresponding sides of these two similar triangles, so in front of this single dot I am having B here in smaller triangle, whereas in the bigger triangle in front of this single dot we are having A dash B, which is K. Then double dot angle, in this smaller angle it is A here, and in this bigger triangle it is 2 here. In front of double dot this side length is 2, and then in front of this 60 degree we are having AC dash, which is K here. 60 degree in smaller triangle, in this smaller triangle APC dash, this is K here, and upon it will be AA dash here. AA dash here. Okay, so what we have got from this, what we are trying to find out, we are trying to find A and B in terms of K, so that we can find T in terms of K. That is the ultimate goal here. So we are getting B to be K square upon AA dash, and we are getting A equal to 2K upon AA dash. Okay, now if I use this AA dash from here, which is actually A plus B plus T, okay, and let me use these values of A and B here. So we will be getting K square plus 2K upon AA dash plus T. Okay, from this the value of T would be, this will go that side, I think we will be getting AA dash square minus K square plus 2K after taking this AA dash to be LCM. It can be verified, this will be going that side. So AA dash square minus this thing, yes, and AA dash square is this. So if I put this value here, K square minus 2K, so K square will be cancelled, and we will be having 4 minus 4K, I think 4 minus 4K in the numerator, and AA dash is under root of K square plus 4 minus 2K. AA dash is this thing, and that is what we are looking for. I think this completes the solution of this question. See, this question in which only equilateral triangle is to be proved was not that difficult, but this other part was little tricky. Okay, I tried to solve this in another method also, where I plotted one line like this which is parallel to this AA dash. So using that BPT, basic proportionality theorem also, we can find A and B in this manner, but I think this one is the best method. The way I have done here I have not found easier than that.